Hi, I'm Trev Lucas Bawu. You've seen me on a number of educational videos, such as Environmental Science, Wave of the Future, Part 4, and Does Environmental Science Apply to Countries like China, North and South Korea, Vietnam, Thailand, Cambodia, Myanmar, and India, as well as every other country on the planet? Part 2. All right, guys. So, this is a conversation we have to have regarding a dirty matter. And that is talking about the basics of soil. So, we got to get to the bottom of it. And it's going to be a rocky trip. And I can't say that you guys won't end up with dirt on your hands. But by golly, we'll get through this dirty matter, no matter how rocky it is. So, before we go, get the sand out of your shoes because we're going in. All right. So, what is soil actually? I looked around different. I wanted to go and find better definitions than what I got, so I looked around. Okay. And the thing is, soils are complex mixtures of minerals, water, air, organic matter, and countless organisms that are the decaying remains of once living things. It forms at the surface of the land. It is the quote unquote skin of the earth. Soil is capable of supporting plant life and is vital to life on earth. Well, duh, we grow food. That's how farmers grow food in it. Okay. And I told you where I got the quote from. Now, of course, the next question is where does the soil come from? Well, yeah, God made it, but here's the thing. We have to look at soil forming factors. So there's several. Parent material. What is the bedrock? The bedrock underneath the soil is where you get the basic material for the soil because the bedrock underneath kind of breaks up and it works its way up. Climate. That's another thing that does form soil. If you have warm and moist climate, then that means soil would actually form faster because organic material would decay faster and make the soil more rich. If you look at places like Yosemite, the process is slower, but in the winter, you can have snow go in between the cracks of the rocks, freezes, expands because that's what water does, and breaks off pieces of the rock, and that helps form the soil there. But again, this is a long process. Living organisms, earthworms, are great for making soil. Okay, they eat the dirt, so to speak, and they poop it out, and that helps form soil and make the soil more rich in nutrients. Topography, shape of the earth. Is it a valley? Is it a hill? Is it a mountain? Okay. Is it rocky terrain? Okay. Um, those are all things there. Now, the other soil forming factor is it takes time. It does take a period of time for soil. Sometimes it can be a really long process. Okay. But at least with that long process, you're not hearing all the dirty jokes that I have been talking about in this entire video. And no, I can't get in trouble for using the term dirty joke because I've told you a lot of dirty jokes, especially at the beginning of this particular thing here, and they all related to soil. Okay, so let's move on. Now, if we look at what's the average composition of soil, all right? Well, 45% of it are minerals like clay, silt, sand, gravel, stones. 25% of it is water. And again, it depends on how much precipitation, what's the water holding capacity of the soil. And I would have had you guys work on that at the very end of the year. We would actually do a lab on that. 25% of it is air. Yeah, because it's kind of an important ingredient for living organisms. Okay, so it's not all just dirt and rock and dead stuff underneath the soil. You have air pockets there. This is what also allows soil to hold on to water. Now, case in point, here, I'm going to say at least in Southern California, if we get a lot of rain, and then after the rain, you notice how worms are coming and they're on the cement. That's because when the water comes down, it fills those pores, those holes in the soil with water. The worms have to get out because they are drowning. That's why they have to come out. Okay? Pro tip. Okay, 5% is organic matter or humus. Or I shouldn't say humus, it's humus. Not to be confused with hummus, the bean paste. Okay? Now, that humus is made up of both living and dead organisms. Now, if we were to go and look at the soil profile, they have what are called horizons. These are layers. Okay. So when we look at them, the topmost layer, and this is where I would refer to you guys to here. Okay. Now, there is an A, B, C layer here, but the top layer, we call it the O horizon, and that's short for organic. Now, this is where you're going to get leaves, needles, twigs, moss, lichens, other organic material. It is dark because the decomposition of all that stuff is producing the humus, the organic material. Right underneath is the A horizon, and that's mainly minerals, okay? This is where a lot of the root activity occurs, and that's usually the most productive layer of the soil because even though plants do the photosynthesis, they still need some raw materials that they get from the soil itself, like phosphorus, nitrogen, potassium, but they'll also get other things in micronutrient amounts. Okay? E horizon is more whitish, it's bleached, because what's happening is as water goes into that horizon, minerals and nutrients will dissolve. And sometimes it gets washed out, it's leached out. Okay. And again, the main feature of this horizon, a loss of silicate clay, iron, aluminum, humus, or some combination of these, leaving a concentration of sand and silt particles. Now, this is a typical soil that you would have. Is every soil across the planet have these exact horizons? No, no, they don't, and that's for various reasons. Okay, now below the A or E horizon is the B horizon, the subsoil. Okay, usually it's lighter colored, denser, and lower in organic material than the A horizon, but that's where the leached material, okay, that's been washed down from the upper regions, that's where it accumulates. Okay, then you get the C horizon, the substratum. Okay, it's going to consist of less clay or other less weathered sediments. Okay, you get some partially disintegrated parent material like bedrock and mineral particles. And then beneath the sea is the R horizon, and that's what they call the bedrock. Okay, now the bedrock can be within a few inches of the surface, it can be many feet below the surface. Okay, and again, to simplify here, typically, or like a layer A here, a layer B here, a layer C here, and then the layer D here. That's like a quick version of these simple soil horizons. But I need you guys to understand what's involved with the soil and how important that is to environmental science. Okay. Now, let's get into soil particles, types, and sizes. Okay. You got three basic types: sand, silt, and clay. All right. Going with the largest to the smallest, sand is the largest. Silt is in the middle. Now, normally you'd find silt at the bottom of a stream bed. Okay. That's where you would typically find it. Clay, on the other hand, it is the smallest. Now, the thing about the clay is we use that to make ceramic pots. And the reason for that is when we fire it up, when we heat it up, okay, the clay solidifies, it hardens, and that prevents water from leaking out. You will have a problem of water leaking out of silt. You will have problems with water leaking out of sand. And that's a huge difference. Clay prevents the water from moving any further. Okay. Now, there are ratios of these. All the soils have these particles in them, but they occur in different amounts. And that is where we talk about sandy loam, Loam, or clay. Okay, those are your three main types of soil. Now there's other categories underneath. Not going to worry about that here. That's another dirty matter for another dirty discussion on a rather rocky situation. You thought you were done, weren't you? Okay, so sand, silt, and clay. This is a soil texture triangle. So we can go, if we were to go and analyze our soil sample, where we could separate it from clay, silt, and sand, we can go and actually identify the kind of soil that it is. So let's go for an example here. I am going to, let me see. I don't know if I can get away with this. Hold on one second. And we're back. Hey, I want to show you how to read a soil textural triangle. A little bit of practicality. On diceroller.co, there is a D10 roller. Oh my gosh. So we're generating numbers between 0 to 10. Now, for the sake of argument, we're going to go and say the first dice. Come on, where are you? The first dice here is going to be sand. Second one will be silt. Third one will be clay. So I'm going to hit the roll button. And I got a 9, a 7, and a 9. Sand, silt, clay. So that's going to match 90%, 90% sand, 70% silt, 90% clay. So I'm writing it down. Sand, 70% silt, and 90% clay. All right. So now we're going to go to this soil textural triangle. And I'm going to go for the sand first. Now the sand said 90%, so I'm here. Now the clay, so that means it's somewhere here, which means that if you were to go and take a ruler, you could go and put it there. The silt is 70%, so that means you can put the connection there between 90 and 70 right here. You guys should be seeing what I'm doing there. Okay, so that kind of, in other words, so from 90% for sand, that's where the 9 of the D10, 10-sided dice, it's a 9, we say it's 90%. Okay, so 90 and 70, okay, so that means all this gets cut off, and then we have 90% here. So we find where do they intersect, and where they intersect, okay, which would be like right around here, that would be my guess, and that would be a silty clay loam soil. Okay. On second thought, maybe that wasn't such a good idea. Scratch that. That's not going to appear on a quiz, okay? But the idea is that, and I just realized it because I can't randomly roll for all three because they all have to equal 10, 100%. So for the sake of argument, let's say I had, well, I'm not going to worry about it. It's really outside of what we're doing here, okay? But this is a soil textural triangle, so there is a way that we can predict what kind of soil we have there. Okay, and I believe that is the end of this. So you had a crash course on dirt. You got into the dirty facts about a rocky situation, and you're groaning. But that's okay, because I'm a dad. And I can tell dad jokes. I can tell cringy jokes because I can get away with it. See, at my age, it's liberating. I'm free. I don't have to impress anybody. Hey, God's awesome. He created this and He has left us, mankind, to understand what's happening and what is it like. It's amazing what soil can do. But you need to have a little bit of a background on soil in preparation, for the exam. Okay, guys, that's it. This is Trev Lucas Spawoo signing off.